Good afternoon. I'm Norbert Ginsen. The first laboratory work, the aim of Albert works the remaining the wavelength using a diffraction grating. The purpose of this work is to determine the wavelengths using a diffractional grating instrument. The first, here is a diffraction grating. Here is millimeter scale screen in this stated ruler, and they are in selling to the optical bench. The first, we must consider the theory. The first, diffraction is the bending of light around and abstractly is next to create a diffraction grating. A diffraction grating is a glass or metal plate on which parallel strokes are applied at exactly the same intervals using a dividing machine. The main parameters of the diffraction grating are its period, their grating constant, and the number of strokes. For example, in this virtual laboratory, the constant of diffraction grating is here. Situated d equal 10 on the power minus 5 meter. Then measurement set the screen at such a distance from the diffraction grating. Measure the distance from the screen to the diffraction grating. Here, the distance between diffraction grating and the screen is here. We get the values to this 30 or 40 or 15H value we can get for this value. Then measure the distance on the screen, the distance between the central band and the spectrum of light. In the same way, measure the distance for all of color spectrum, like orange, yellow, green, blue, dark. The obtain at values of S and R are substitution into the formula, and lambda equal to S drk. Here S is the distance between central band, and is a spectrum. R is a distance between diffraction grating and the screen. D is a diffraction grating constant. K order in this situation. In this laboratory work, K is equal to 1 because it is a virtual laboratory. Then we give the example for the red 30 centimeter. Then red here. The red is S is 2.2 centimeter. From these values, we can find the wavelengths for red in another laboratory. We take the value 40 centimeter, then our distance between central band and the spectrum will change. If they are 3 centimeter, then was a 15 centimeter. The change the distance between central band of the spectrum is 3.9 centimeter. By these values, we will find the wavelength of red, and by these wavelengths, we will find average value. For example, in this situation, 701 nanometers. Then we must find the truth value of wavelength. Here is the truth value of red wavelength 725 756 nanometer. In the same way, we must calculate the wavelength of the color spectrum, like orange, like yellow, under other spectrums. Then we consider the spectrum for 30 September distance spectrum. Then we see that spectrum is situated closer to the central bank, and for 40 centimeters the spectrum is situated far away from the central band. Yes, in conclusion, I see that its wavelength is as long as wavelength, and the violet wavelength is the shortest wavelength among the colors in spectrum. And we take the red, for example, and the distance between central band and the red spectrum is greater than distance between central band and the road spectrum. Here we see that the distance between central band and the red spectrum is greater than violet lilies is. Here is the distance between here red spectrum and the central band above mentioned date. We can say that by increasing the distance between the central band and the spectrum will our wave or spectrum's wavelengths of the spectrum will be increasing they proportional to each other. Then we can see the red wavelength is the warmest wavelength and the bird wavelength is the shortest wavelength. Okay, our laboratory work has ended.